Good day everyone. Welcome back to Azure Databricks series. In today's video, we are diving deep into one of the most powerful performance tuning features available in Databricks, liquid clustering. If you ever use partitioning and z-ordering to optimize your queries, this video is for you because we are going to explore how liquid clustering can often deliver better performance with less complexity. We will walk through when to use it, why it matters, and how it compares to traditional optimization techniques like partitioning and z-ordering. And yes, it's a step-by-step demo, so you can follow along and try it in your own workspace. If you find value in this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future content on Azure Databricks and beyond. Let's jump in and start optimizing. Liquid clustering is a modern, intelligent data organization technique that eliminates the need for traditional data partitioning and z-order based optimization. It automatically optimizes data layout, removing the burden of manual tuning while still achieving high performance queries. Unlike partitioning, which requires predefined static data slices, liquid clustering is adaptive and dynamic, allowing clustering keys to be modified over time without needing full rewrites. This flexibility enables your data layout to evolve alongside analytical workloads, a capability that static partitioning in Delta Lake lacks. We will be using two tables for this particular video. Yeah, one table will be the sales underscore data underscore partition delta table. Yeah, so if you see here, I've partitioned this particular data on the column transaction date. That will be one table that we'll be using, and the second table would be sales underscore data underscore cluster, which utilizes the liquid cluster concept. And if you see here, we are using the cluster by command on the column transaction date. So the only difference between these two tables is that the first table uses partitioning and second table uses liquid clustering. So what we'll be doing is like, we will be basically comparing the performance between the partition table and then the liquid cluster table and see which one is behaving great as far as each of the incoming queries are concerned. Let's run the table row count on the sales underscore data partition table and then sales underscore data cluster, and then let's compare the number of rows that we have on each of these tables just to make sure we are doing a proper comparison between these two tables. Yeah, if you see here, the count seems to be same. Yeah, it's close to like 6 million rows on each of these tables. If you look at it exactly, it is 61 lakhs 87,856 rows on each of these tables. Yeah, so the sales underscore data underscore partitioned as well as sales underscore data underscore cluster both have same number of rows. Yeah, so now what I'm going to do is like I'm going to run this describe detail command for sales underscore data underscore partition table, and then for the sales underscore data underscore cluster table. Yeah, and then let's try comparing the output here. Okay, so if you see here, what I'm able to see is like we have this partition table. If you see a sales underscore data partition, let's look at the number of files. Yeah, so now if you see here, the partition column is transaction date and clustering column is null because we know it's a partition table. Okay, and what I'm seeing is like I have close to like 2,483 files, the Parquet files. Okay, now let's compare this with our clustering table. Okay, the partition column is null because it uses liquid clustering, and then the clustering column is transaction underscore date. But if you look at the number of files, that really makes the difference. Yeah, so on the partition table, we have close to like 2,483 files, But as far as the clustering table is concerned, we just have 6 files. If you notice, what we have done is like we basically created the table and then we did the initial load on each of these tables. Yeah, but after the initial load, what you're able to see is like the partition table has got close to 2,483 files, and then the cluster table, the liquid clustering table, like just has 6 files. This alone shows us like how tables with liquid clustering will perform better, because the number of files really matters as far as the performance is concerned. Yeah, because when you need to read the required data or you need to do some modification, it needs to traverse through the number of files. Yeah, and if the number of files is comparably high, then the performance will also be having an hit, because if you have too many files. Yeah, so with the initial load itself, what we can see is like the table with liquid clustering seems to be looking good. Yeah, so now what we'll do is like, let's go to the catalog fraud, and then look for this sales underscore data underscore partition table. Yep, and what I'm able to see is like, let's go to the details, and if you look at the details here, I'm very much interested on this storage location. Yeah, so we have the Unity catalog enabled, and Unity catalog is a prerequisite for you to create liquid clustering on the table. Yeah, so now what I'm able to see is like, this is the location within this storage account. So what I'm going to do is like, let's head to the storage account, and then let's go inside that, and let's look at the files that we have on that particular folder. Yeah, so if I click on this and then click on tables, let's look at the value here. So it is 9CF60. So let's go to that 9CF. So this is the one, 9CF60F12. Yep, so if you see here, what I'm able to see is like, I'm able to see a lot of folders within this partition table. Yeah. So if you see here, we have one folder created for each partition. So now let's look at the partition details for sales underscore data underscore partition table. And if you see here, we are able to see that we have this many number of partitions within this particular table, sales underscore data partition. And now if I look at the storage account here, yeah, what I'm able to see is like, for each partition we have created a folder, and then within each folder you have the required Parquet files. Yeah, so that is what we are seeing here. So now you just think about it. Now if you want to change the partition column, then basically what happens is like, whatever information we have, whatever folders we have, all these things needs to be reworked, and then you basically have to rewrite the whole data. So that is something that will happen as far as partitioning is concerned. Yeah, now what you'll do is like, let's look at this sales underscore data underscore cluster table here. Yeah, and if you see here, what I'm seeing is like, the data as far as the sales underscore data cluster table is concerned, we are able to see like the size is 290 MB, and then we have close to 6 files. On the other hand, for the sales underscore data underscore partition table, we have close to 2,483 files. But look at the size. The size is close to 450 MB. Yeah. So the partition table is 450 MB, and the size of the cluster table is close to 290 MB. But the real game changer is the number of Parquet files. So for example, if you look at the partition table, it is 2,483 files. On the other hand, the data cluster, that is sales underscore data cluster, which utilizes the liquid clustering, just has 6 files. Yeah. Now let's go to the details here, and then let's get into this particular folder. and then let's look at it. Yeah, so let's go to the containers and then click on that Metastore folder, and then let's get into the required value here so that we will be able to get to that particular table. Yeah, so if you see here, it is 46A1D. So if I need to look at it, this is the one, 46A1D05. It is 46A1D05. Yeah. Now, if you see here, as far as the liquid clustering is concerned, we don't have any kind of folder. Yeah, it is just the Parquet files. And what happens is like the traversing through each of these files is taken care by the metadata. And metadata knows like to go to which file and get the required data. So we don't have this overhead of creating different folders for different partition and things like that as far as clustering is concerned. Yeah. So if you look at the create table command for partitioning and liquid clustering is concerned, we are using the same column named transaction date. Yeah. So it is just like as far as the partition table is concerned, we are using the transaction date, and for the clustering, we are using the same column. The only difference is like with the partitioning, what we are doing is like we are physically creating the folders with regards to the partition that we have on that table, and then we are segregating each of the Parquet files within it. But as far as clustering is concerned, we are not physically creating any folders. Another thing is like as far as partitioning is concerned, you will have to create it for the when you're creating the table for the first time. Yeah, you need to mention that. Like if you look at the command that we have used here, we basically have to first create the table, yeah, with the partition by command, and then you need to do the data load. There is no way you will be able to do a partitioning on the existing table. Yeah, you need to create a new table and then use the partition by command. But as far as clustering is concerned, you will be able to use the existing table with data and then added to the liquid clustering. Yeah. So in case if you want to do that, what you basically have to do is like you need to do alter table name, and then you need to just mention cluster by that column. Yeah. And also as far as liquid clustering is concerned, you can have up to 4 columns mentioned that I'll be discussing further when we pass through other demos in this video. Yeah. Now let's look at the key difference again. As far as the partition table is concerned, you have physically created folders, and you need to segregate the Parquet files within it. So whenever you do the partitioning, all these things are taken care by Databricks. And now in case if you feel like the partition column needs to be changed, then what happens is like it has to basically redo everything. On the other hand, liquid clustering, if you want to change the clustering column, it doesn't require any kind of a rewrite. Yeah, it basically has to change the metadata and then it has to carry on with it. So that wouldn't be much of a problem. Yeah. Now what we'll do is like we will try executing these 2 queries. Yeah, the first query basically utilizes table sales underscore data underscore partitioned. Yeah, and then the second query, which is same as the first query, the only difference is like the second query uses your liquid clustering table, which is sales underscore data underscore cluster. Yep, so let's wait for this query to complete. What we're basically doing is like we are having the predicate as transaction date, which is your partition column. And for the liquid cluster table, we are using the transaction date. Again, it is the clustering column for this particular table. And then we are doing some aggregation. So what we'll do, let's wait for each of these queries to complete, and then let's compare how long did each of these queries took. So if you look at this, the first query that ran on sales underscore data underscore partition took close to like 40 seconds, 39.98 seconds. Let's look at the second query and then let's compare the time taken. If you see here, this query took close to 23.49 seconds, close to 23 seconds, yeah. And now when you compare this with the same query that ran on the partition table, it took close to like, yeah, 40 seconds. Yeah, so we were able to improve this query, even though the data is same, everything is same. It's just the underlying concept is different. The first one uses partition and second one uses cluster. We are able to save close to like 17 seconds. Yeah. Now what we'll do is like we will run another query. So if you see here, it is both these queries are same. The only difference is like the first query uses the sales underscore data partition table, and the second query uses our liquid clustering table. Yeah. So what I'm basically doing is like I'm basically querying this partition table, and then checking the predicate is on the transaction date, which is your partition column, and then I'm basically looking for 1 year day, 1 year data, that is 1 Jan 2024 to 31 December 2024, and I'm having a group by on transaction date, and also like I have a having clause for total underscore sales is greater than 100,000. Yeah. So now if I compare the time taken, so the query on the partition table took close to like 20 seconds. Yeah. And the query on the clustering table took close to like 13 seconds. Yeah. So what I'm able to see is like we were able to like save like 7 seconds as far as the same query execution on the clustering table. Yeah. So we tried two queries and two same queries. The only difference is like the tables, underlying tables, and what we are able to see is like on both the occasion, the queries on the clustering table really performed well. Yeah. Before moving on other demos, let's discuss on the challenges with traditional partitioning on Z order. Yeah, partitioning strategy is kind of very hard to get right. Yeah, selecting the appropriate partitioning columns is often a trial and error process. If the partition column isn't chosen carefully, it can lead to poor read performance, either because files are too large, maybe low parallelism, or too small, excessive metadata and IO overhead. Z-ordering comes with trade-offs, lot of trade-offs to be frank, and if we discuss some of that, we know that Z-order really improves read performance over basic partitioning by co-locating data with similar values. It is computationally expensive. Yeah, it involves full table rewrites, cannot be performed during writes, and doesn't optimize data globally, which can lead to suboptimal query performance. Additionally, Z-order jobs increase compute cost and it introduce write amplification, especially on large data sets. Liquid clustering overcomes all these problems by automating data layout optimization. It intelligently arranges data files based on the clustering keys that you define, adapting over time to changing query patterns and delivering performance benefits for both reads and writes without manual tuning. Moving on, let's try eliminating some partitions. Okay, so let's execute this query and then let's look at what kind of data we have. Yeah, so if you see here, I'm able to see 3 months of data. Yeah, so for the January month, I have close to like 3 million rows. For the February 2024 month, I have close to like 2.9 million. And then for March 2024, I basically have 100,000. Yeah. So this is what I have checked as far as sales underscore data partition table is concerned. Let's check for sales underscore data underscore cluster. Yeah. So now if I check the data on the sales underscore data cluster, what we can see is like as far as January 2024 is concerned, we have close to like 3.1 million, and for February 2024 it is 2.9 million, and then for March it is like close to 100,000. So the data seems to be like, we know that the row count is same, and also like what I'm seeing is like we have somewhat similar data within each of the months here as far as 2024 year 2024 is concerned. Okay, so now what I'm going to do is like I'm going to run these two queries. Yeah, and what I'm basically going to do is like instead of one full year, I'm going to just get data for 1 month. Yeah, that is from 1 January 2024 to 31 January 2024. The query is same. Yeah, the predicates are all same. The only difference we have for this query, we have the partition table, and for this query, we have our sales underscore data cluster table. Yeah. So previously we were bringing in close to 1 year data. So there we couldn't get any kind of partition elimination at all because this particular table just has 3 months data. Yeah. Now I just want to do some sort of an partition elimination. So that's the reason what I'm going to do is like I'm just going to bring in 1 month of data. Yeah. Now let's execute the query for both partition table as well as the cluster table, and then let's compare the performance for each of these queries, and let's see if eliminating the partition is going to help us here. What I'm seeing is like the query on sales underscore data underscore partition took close to like 27 seconds. Yeah. But on the other hand, if you look at the same query that executed on sales underscore data underscore cluster, it just took like 6 seconds. So what I can see is like this query kind of performed 4 times better than the same query on the partition table. Yeah. So this is the power of liquid clustering, wherein without changing anything, just introducing liquid clustering, we are able to get close to like 50% or 4x performance returns. Yeah. Now, what if we use a non-partition column? Yeah. So all these demos were basically using the partition column or the clustering column as far as the predicate is concerned. Yeah. Now, what we'll do is like we will try using a non-partitioned or non-clustered column and then see how it performs. Yeah. Let's execute these queries, and if you look at this query, what I'm basically doing is like I'm querying the sales underscore data partition or the sales underscore data cluster, and the predicate is a non-partition column, which is unit underscore price, and then I'm doing a group by, and then having a and using the having here. So if you see here, the query on the sales underscore data underscore cluster took close to like 35 seconds. Yeah. But the same query on sales underscore data underscore partition took close to like 41 seconds. Like we were able to save close to like 6 seconds by using the liquid clustering, even though the predicate uses a non-partitioned column or a non-clustering column. Yep. So even in this test, what I'm able to see is like liquid clustering seems to be working better as far as the performance is concerned. As you can see, queries comparatively performs well on table with clustering compared to partition table. Yeah. To be frank, clustering is very, very simple and flexible. Like you checked the table, the command that we used is like we use just the cluster by. It's very simple, and it also like reduces the complexity of the data layout planning. Yeah, unlike the hive style partitioning, where cardinality, ordering, and skew must be considered. liquid clustering lets you choose clustering keys solely based on query patterns. Yeah, if you look at the partitioning, what happens is like if you select column with high cardinality values, then you might get a lot of partitions, and also like the data distribution will have a huge problem as far as partitioning is concerned. But in liquid clustering, you don't have any problems of that sort. Yeah, so it works better on a huge table, and also like if the data distribution is not fine as far as the clustering key is concerned, still the performance will be better when compared to liquid clustering, and when you compare this with partitioning. Yep, like if you have too much of data distribution, the queries are going to really have an impact as far as partitioning is concerned. But on the clustering, that is something that you will not see much of an problem when compared to the performance on the partitioning and on the clustering table. Yeah, and liquid clustering is kind of a self-optimizing, and it is resilient to skew, maintaining consistent file sizes while avoiding both over partitioning and under partitioning scenarios. And writing to liquid clustered tables is efficient and cost effective. It enables incremental clustering, reducing the need for expensive full table Z-order jobs. Yeah, because there is minimal write amplification, write operations are significantly faster than what you would get with partition plus Z-order tables. Since liquid clustering automatically organizes data according to the defined clustering keys, query pruning becomes more effective, especially on frequently filtered columns. There is no need to run separate optimization jobs as often. And also like Databricks handles layout improvements behind the scenes. Yeah, and as far as the liquid clustering is concerned, you can have multiple columns as far as the cluster by command is concerned. So if you see here, what you can do is like you can have multiple columns. And now let's say you have a query that basically has more than one predicate, which is normal. Then what you can do is like you can have multiple columns in the cluster by. The only thing is like now, for example, let's say you have column 1, column 2, column 3, and column 4 in the cluster by. Then what happens is like if you get a query, for example, if the predicate is column 5, then there is high possibility it might not perform well than the query which has got the predicates column 1, column 2, column 3, and column 4. Yeah, that's same as far as partitioning and cluster by is concerned, the liquid clustering is concerned. But the thing is like we saw that using an column that is not used in the clustering predicate, what we were able to see is like it was performing better than partitioning. So what I'm trying to tell is like this is definitely liquid clustering is better than partitioning in terms of using a non-clustering key in the predicate. Yep, that's something clustering really does a great job when compared to partitioning. Yep. So now what we'll do is like let's try running the optimize command on the partition table and the liquid clustering table. Yeah. Before that, let's look at the number of files one more time. So if you see here, the partition table has got close to like 2,483, and the clustering table has just got six Parquet files. Yeah. So now let's run the optimize command, and then let's check the output one more time for the described detail once optimize is completed. Okay, so the optimize completed. Yeah, so now let's run the describe detail for data partition, sales underscore data partition table, and then for our clustering table. Yeah, so now if you see here, even after running the optimize command, we are just seeing 6 files. Yeah, and now if I look at the partition table, I'm able to see like 61 files even after completing the optimize. This is like 10 times greater. Like, yeah, the cluster, the liquid clustering table just has like 6 files, but on the partition table, still we have 61 files, which is like close to 10 times more than the liquid clustering table. Yeah. On our next video, we will discuss about automatic liquid clustering. And we will see like how Databricks itself decides the clustering column for the underlying table. That's it for this video. Thanks for watching. Have a great day. Jai Hind.